Hi there, this is an Algebra 1 video. It is Chapter 7, Section 6, and today we are talking about growth and decay, part of the exponential functions family. And so first I want to start with our formula for exponential growth, and this is what the equation looks like. It looks like y equals a times 1 plus r to the t power. And so here what I have on the board for you is basically a key, if you will, for each of the variables so that you know what they're for. Y represents the final amount, A represents the initial amount, and then R represents the rate of change. And it's important that when you input R, that it's always in a decimal. In other words, 5% would be transferred, or as a decimal would be 0.05, and so on. But of course, if it's going to be growth, then the value of R should be positive, greater than 0. And then T is time. So we're going to go ahead and show you some examples of how this works. The prize for a radio station contest begins with a $100 gift card. So that would be our initial amount. So that's going to be our 100. And then it says, once a day a name is announced. The person has 15 minutes to call, or the price increases by 2.5% for the next day. So 2.5% needs to be transferred into a decimal, and you can move the decimal 2 places to the left and then put the 0 there, so it would be 0.025. Or if you prefer, you can take the 2.5 and divide it by 100, and that will also give you the decimal that you need, which is 0.025. So whether you move the decimal 2 places to the left, or if you take the 2.5 and divide it by 100, you get a decimal point that is right here, 0.025 for the next day. So it says in part A, write an equation to represent the amount of the gift card in dollars after T days with no winners. So this would basically be my equation. I can simplify that because I can take 1 plus 0.025 and simplify my equation so that it's y equals 100 times 1.025 to the t power, and this would be my equation. Now once I have the equation, I can actually answer part B. How much will the gift card be worth if no one wins after 10 days? So basically I want to know what will be the final amount when t is 10. So I'm going to go ahead and replace my t from the previous equation with a 10 and then solve it. Now it's very important that you follow PEMDAS here. A lot of times students want to multiply 100 times 1.025 and then raise that to the 10th power. That number will be way too big. So if you recall, PEMDAS tells you to do parentheses first, then exponents, then multiplication. So when you take 100 times 1.025, that's multiplication. And then when you raise it to the 10th power, that's exponent. So you've reversed the order in that situation, which is not what you're supposed to do. So you want to do the exponent first, which means that before we multiply, we're going to deal with the exponent, which is 1.025, and raise that to the 10th power. So I have 100 times 1.025 to the 10th power is approximately 1.28, okay, based on my calculator. And then now I multiply the 1.28 times 100, and now we get that after 10 days the prize will be $128.01 if you round it up. It's 128.00845. So 008, I'm going to round that second 0 to a 1. I'm leaving it at only 2 decimal places because we're talking about money here, and so we don't want to have more decimal places than that. So $128.01 after 10 days if no one wins the prize. So now I want you to try this guy in much the same way, and then we will move on to our next application of growth. One of the applications of exponential growth is compound interest. Now compound interest is interesting because It's when you have earned or paid interest on not only the initial investment, but also on the previously earned interest. So for example, you have $10 and let's say that you're earning 10%. 10% of $10 is probably going to give you $1. So what that means is that you initially invested $10. So the first time that you get interest on that, they take your $10 and times it by 10%, and that's $1. So now you have $11. And so that's what it means by both the initial investment was $10, and then you earned $1, and now they're going to give you more interest, but it's going to be based on the $11 now. So you're going to get $1.10. And now that's going to be added to your $11. Now you're going to get $12.10, and on the story goes. If it wasn't compounded, what would happen is every time you'd only get $1. $1, $1, $1, because you'd only be getting interest on the initial investment, which is the $10. But when you have compound interest, they're giving you interest on the initial investment and also on the previously earned interest. So hopefully that makes sense. But again, we have a formula, and this is our formula for compound interest. And it says A, which is the current amount of your investment, is equal to P, the initial amount, times 1. So it's very similar to our other equation, 1 plus R, but now it's 1 plus R over N. And instead of it being raised to the T power, it's raised to the NT power. So R, again, is the interest rate as a decimal, and it should be positive. N is the number of compoundings per year, and I'll explain that in a bit. And then T is your time in years. Now, compounding means how many times a year you're going to get this interest. If you are compounded annually, it means once a year. If you are compounded monthly, that would be 12 times a year. If you are compounding weekly, in the fiscal world, we use 52 weeks in a year. It could be compounded semi-annually or biannually, which means 2 times a year. It could be compounded quarterly, which means every 3 months, so 4 times a year, and on the story goes. So if you're compounding quarterly, it means that you're going to replace the n with the 4. If you're compounding monthly, you're going to replace the n with the 12, and if you're compounding weekly, you replace the n with the 52. If you're compounding daily, that's 365 times a year, so then you would replace the n with 365. So, we'll go to our example here. Maria's parents invested $14,000 at 6% per year, compounded monthly. So that means that for our purposes, n is going to equal 12. We also know that it says here, how much money will there be in the account after 10 years? So T is going to be 10 years. And then we have our interest rate, which is 6%. So that's going to be 0.06. Remember, you can either move the decimal point, which at this point is behind the 6, move it once, move it twice, 0.06. Or you can take 6 divided by 100 and still get 0.06. All right? And we want to know, what do you want to know here? The amount. So the principal here, the initial investment is $14,000, and so they want to know how much will be in the account at that point. So we pretty much have everything that we need. So now we're just going to say that A equals the principal amount, $14,000, times 1 plus the interest rate, which is 0.06. We're going to divide that by the number of compoundings, and then raise it to the n times t, and time was 10 years. So now we have everything in there, and again we want to make sure that we follow our rules of PEMDAS, and so parentheses go first, so we need to figure out what this is going to be first. So we're going to take 0.06, divide that by 12, and that gives me 0.005. And then I add that with the 1, and I get 1.005. I still have the 14,000 over here. And then 12 times 10 is 120. So I've done my parentheses first. Now I'm going to go to my exponents, which is to take the 1.005 and raise it to the 120th power. And that is 1.819 times the 14,000. Okay, so that times 14,000 gives me a whopping $25,471.55. Again, we're going to only use 2 decimal places because we're talking about money here, and we only use 2 decimal places when we're talking about money. So $25,471.55 to lose. All right, so now we're going to ask you to do this little guy. And then we're going to talk about decay. And decay is pretty much the same thing as growth, only of course you're not increasing in value, you're decreasing in value. So this is our equation for decay. It looks very much like our growth equation, only it has a minus instead of a plus. And of course all the variables still represent the same thing. I want to point out that for the interest rate, your value is going to be less than 1. You want a value of R that is less than 1, but bigger than 0, okay? So your interest rate is going to be somewhere between 0 and 1. So you can have an interest rate that is larger than 1 and call it decay. All right, so here is our example. It says a fully inflated child's raft for a pool is losing 6.6% of its air every day. So see, it's losing air, so that's how we're going to use the decay formula. The raft originally contained 4,500 cubic inches of air. So the first part is to write an equation that represents the loss of air. So we're going to go ahead, and I think A is my initial amount, okay? So we're going to say that Y equals our initial amount. The initial amount of air contained in the raft was 4,500. And this time we're going to go 1 minus R. And our interest rate is 6.6%, so we want to move the decimal place 1 twice. So it's 0.066. And then we want to raise that to the T. And it says, there we go. All right, to the T power. That's going to be our time. So now again, if we want to simplify, we can take the 1 minus 0.066 and get our equation to be Y equals 4,500 times 0.934 to the T power. So this is our equation for part A. And then we want to answer part B using our equation. It says to estimate the amount of air in the raft after 7 days. So we're going to take our equation and replace the T with 7 for 7 days. Alrighty, so now we are going to remember once again PEMDAS, so we don't want to multiply first, we want to raise this to the 7th power. So 0.934 to the 7th power is going to be roughly 0.6201, like so. And then we're going to multiply that by the 4,500 so that we get 2790.2. But again, this is talking about cubic inches of air, so we can actually round that up, or sorry, round that down to just 2,790 cubic inches. So here we go. We can round that cubic inches of air. So that's example 3 for you. And now you will have to do this do-it-yourself question. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.